Hello, everyone. Welcome to video 1-6. In this video, we're going to be locating points on a coordinate plane, and we are on page 43 for your notes beginning today. The goals of our lesson are going to be to find a point on a directed line segment. We learned what that was in the last video. On the coordinate plane this time, not just on a number line, that is a given fractional distance from the initial point. And the second goal would be to find a point that partitions that directed line segment on the coordinate plane in a given ratio. So that's the same idea of like the M to N ratio that we talked about last time. Know that we modified our process for lesson 1-5 when it came to this ratio work. We're going to be doing the same thing here on the coordinate plane as well. So get ready to modify your book's notes a little bit. All right, our first learn is that we're going to be locating points on the coordinate plane that are a fractional distance from the end point on the coordinate plane. Remember, the initial point is the start of the endpoint, the terminal point is the end of the endpoint in what we call a directed line segment. Our key concept here, you can see, hopefully, that we have some very similar structure to what we used in lesson 1-5. So the coordinates of a point on a line segment, that is A over B, that's the fractional distance of the distance from the initial endpoint, which we're still calling x1, y1, to terminal point x2, y2 are given by, and then here is our coordinate formula. One worked out for the horizontal, the x coordinates, and the other coordinate created from the vertical, the y coordinates. So our first example, 1, is to find a point C on segment AB here on the coordinate plane that is located 3/4 of the distance from A to B. The first step in this process is to identify what are the initial and terminal points. Remember, they said from A, that tells you what the initial is, and to B, that tells you what the terminal is. So x1, y1 are the coordinates of A, which are -7 and -5. And x2, y2 are the coordinates for B, which is 6, 8. In step 2, we're going to find those x and y coordinates and actually do the arithmetic of the fractional distance formula, or the coordinate formula is another way to say it too. But notice we have this worked out and ready to be substituted in for our x coordinates and for our y coordinates. So let's do that. Remember that our x1, y1 was -7, -5. So x1 is going to be -7, y1 is going to be -5 in our blanks. And a over b, 3/4 of the way, has been entered in both places. So we can go ahead into the differences inside each parenthesis. X2 and x1 are going to be 6 and -7. Remember to take the x coordinate from each point, A and B. And then our y coordinates are going to be, y2 is 8 and y1 is -5. Lots of parentheses going on here because of all of those minus negatives. So make sure you're keeping track of all of that. All right, so if we simplify, we know that this becomes 13, and this becomes also 13. So we're going to have -7 plus 3/4 of 13 over 1, if you would, and -5 plus 3/4 of 13 as well. Now, because we're dividing by 4, this is another case of a terminating decimal. Just like when we divided by 2, we got a 0.5 in some of our answers. This is a terminating decimal as well, because we're dividing by 4 rather than a messier number like 3 or 9. So we can go ahead and just create decimals with these. -7 plus 3/4 of 13, or if you want to simplify even further, -7 plus 39 over 4, and -5 plus 39 over 4 again. We get positive 2.75 and positive 4.75 for the coordinates of C. And I do want to note that this is a special case here in example 1, that the added value to each one of the initial coordinates happens to be the same number. That is only because if you look at the slope of segment AB, it's exactly 1, which means for every unit it goes over, it goes up that same amount, right? So each of the 3/4 amounts are also going to be equal. Okay, follow that process yourself here on example 1's check. We are finding point P on segment QR, that is this time 1/6 of the way. This is a divide by a factor of 3 fraction, so just caution, you're definitely going to want to keep things as fractions. Maybe you want to write that as a note to yourself here. All right, as we get started learning our next concept, which is locating points on the coordinate plane still, but this time with a given ratio of how we divide that segment. This goes back to what we were doing in lesson 1.5 as far as using a modified coordinate formula that will be used in this manner. All right, so in the key concept area, you have my full permission to go ahead and cross out that section formula. Cross that right out and be using the idea of the modified coordinate formula, just like we were in the last video, but we're going to need to expand on that a little bit so that we are expanding a version of that for both X and Y. And the other modification is, remember that the ratio that we're given is going to produce our A over B fractional value in front of each one of those differences. And that comes from, remember, the front part of the ratio, M being in the numerator, all over M plus N, meaning the full length of how many parts the full segment is broken into. So putting this into practice in example 2, if we want to locate a point on the coordinate plane with the given ratio this time being 1 to 2, a reminder of what that means is that there are 3 parts for the entire segment to be broken into in total. And so my A over B fraction is going to be M over M plus N, which in this case is going to come out to be M is 1, and then the total number of parts is 3. So we're going to go 1/3 of the way from point A to point B. And here's just recopying some of that information from your diagram. So your x1, y1 is point A, which is -5, -2. Your x2, y2 is point B, which is 6, +2. And then as we're starting to put that into our formula, remember the fraction of the distance that we came up with on the last slide was 1/3. So my C value can be recalculated here, not with that really crazy alphabet soup equation that you see in your book on page 44, but with a modified coordinate formula, as you've seen me flesh out here. So go ahead and copy this down from what we just talked about, that we're going to use that fractional distance formula for the X coordinates and for the y coordinates, okay? So as we do some substitution here, we're going to get that c is equal to -5 plus 1/3 of 6 minus -5, comma, -2 plus 1/3 of 2 minus -2. Close off the negative, close off the subtraction, and a final parenthesis to close off the coordinates. Now, hopefully you're seeing again the factor of 3 as a divisor. That means, again, we're going to want to keep things in fraction format, not decimals. So simplifying this, we get -5 plus 1/3 of 11 and -2 plus 1/3 of 4. So some of the simplification arithmetic there, we're going to do -5 plus 11/3. And we can think of that -5 as -5/1. So in thirds times 3 in both parts of that fraction, that would be -15 thirds plus 11 thirds, which as you can see is giving us -4 thirds for our x coordinate. And then simplifying our y's, we would have -2 plus 4 thirds, -2/1 times 3 in both. That's -6 thirds plus 4 thirds, or our y coordinate coming out to -2 thirds. Take a pause on this video as you come up with the coordinates for point S here. And I am on page 45, at the top of page 45 for this check. And you're going to want the partitions this time to be in the ratio of 2 to 1. All right, our last example is going to be, again, partitioning our directed line segment, but in an application setting. So we're talking about a zip line ride here. It says Kendrick is riding a zip line, and the zip line is 1,800 meters long and starts at a platform 600 meters above the ground. After he jumps, someone takes a picture of his descent, kind of like those snapshots you get from roller coasters. When the picture is taken, what you're told is that the ratio of the distance Kendrick has traveled to the distance he has remaining to travel is 1 to 2. The picture is going to show obviously a finite window, and that window is from 400 meters horizontally to 1,200 meters from the base of the platform, and then the vertical distance is just ground level up to 500 meters. So the question is, will Kendrick be in the frame of that picture? First thing we need to know here is, what is that horizontal distance that the zip line is traveling? So to do that, we are going to use Pythagorean theorem, as you can see in your book. And so we filled in all of those values. A squared plus b squared equals c squared for Pythagorean theorem. A reminder, of course, that anytime we're placing c into this theorem or equation, that c is always the longest side, this right here being the longest side of this triangle. It's also known as the hypotenuse, as we will get to later this year, learning more about right triangles. But for now, just Pythagorean theorem gives us, remember, we're squaring each of the values first. In this particular case, because we're finding x squared here, we need to get it alone by subtracting 600 squared from both sides. And so we get, when we take our square root, right? The square root is the operation that gets us from x squared to x. We get 1,697.1, and that is the distance horizontally that the zip line extends. So in the next step, you'll notice that we have put that quantity here from step one into the x coordinate of the end of the zip line, right? If we're at the bottom, then we're at 0 height. So we're going from a platform 600 meters in the air. Kendrick is traveling all the way down to the ground. The question is the portion of his ride within the picture window? So a reminder that the ratio of the zip line is 1 to 2, which means we have 3 parts total, and that our A over B is going to be 1 out of 3 total parts along the distance of the zip line that we are. Our X1, Y1 is the top of the zip line, the point 0, 600, and our X2, Y2, bottom of the zip line, or that value 1697.1 comma height of 0. So let's substitute that in to our work here to find where Kendrick is at. Kendrick is starting at 0 and going 1/3 of the horizontal distance, which we know is 1697.1 from our square root work. And the height that he's starting at of 600, we're going to go 1/3 of the distance. And notice the zip line is sliding down, right, in a downward direction. That means the slope is negative. So be really careful how you place this y2 and y1, right? Y2 we know is 0. Y1 is 600. So this subtraction does need to still go 0 minus 600. And that will allow me to see a negative 600 in that parenthesis. And so that means, of course, we're going to go down in our height. And if we simplify that, we get, so that's where the value 565.7 comes from, right here in this calculation, 1/3 of our horizontal distance. And the blank that you would need to fill in is we get a height of 400, right? Because we would have 600, actually minus 1/3 of 600, which would be minus 200. And that gives me 400. So the question is, when I plot this point, is Kendrick within the window? And our answer is yes, he is in that blue rectangle. So the picture will include him. Our last check for the video today is an example 3, another application problem. This time we have a travel example of traveling from Jeffersonville to Springfield. And this time we have a ratio for the distance to be 3 to 7 parts there. Okay, everyone, this is the part of the video where you really want to check back on the answers to those checks that were assigned to you as you were watching. All right, looping back through our checks, go back to page 44 for the check on example 1. We're finding point P on segment QR that's 1/6 of the distance, that's missing from this slide, of the distance from Q to R, as you can see in your book. Just write that in. Okay, so our X1, Y1 is going to be point Q. Do keep in mind that the scale here is not equal, okay? Our X scale is equal to 1, but our Y scale, as you can see, we're counting by 2 for each block. So be careful of that when you transcribe from the grid to what the coordinates are. X1, Y1 is going to be point Q And that comes out to -2, -5. Our x2, y2 is point R, which has the coordinates 4 and 7. And so our coordinates for point P are going to be, take my first point, -2, -5 for my x1, y1, and we want to go 1/6 of the distance and find those differences. Those differences are for the x coordinates 4 minus -2, and for the y coordinates 7 minus -5. Extra parentheses there. All right, notice our divisor of 1/6 is, or of 6 in the denominator. It's a factor of 3, so we want to keep things with fraction mode here. We have -2 plus 1/6 of 6, comma, -5 plus 1/6 of 12. Well, this comes out nice here, and this comes out nice here. So actually, we don't need to keep fractions because we have everything coming out quite nicely to integer values, numbers without fractions or decimals. And our P point is at -1, -3. So here we go, -1, -3, right about there. Okay, let's plot that point. And hopefully that makes sense that we are 1 out of 6 parts of the way from Q to R. Our next check is at the top of page 45, you guys. Our partition was 2 to 1, which means that our A over B is going to be 2 out of 3 total parts. Our x1, y1 is point Q, which is -2, -5, no change in scale on this graph. And R is 4, 7. So x1, y1 is our -2, -5. And our x2, y2 is 4, 7. So our point S is going to be found at 2/3 of the way from -2, 5. And those subtractions are 4 minus -2 and 7 minus -5, which comes out to be -2 plus 2/3 of 6, which again simplifies nicely, and 5 plus 2/3 of 12, another nice multiplier for the divisor of 3. And simplifying that out, we get -2 plus 4, 2 times 2, the leftover factor, and 5 plus 8, 2 times 4, the leftover factor. And I'm realizing that I actually forgot these negatives in front of each one of these 5s. So make sure you go back through and do as I do, not as I said initially. And just a final simplification here. Of course, that gives us the point 2, 3. Let's plot that point 2, 3. And that ratio is, of course, 2 parts to 1 part on the end there. Final travel check here at the bottom of page 46. Remember, we have an M to N ratio of 3 to 7, which is 10 parts total. So that means our A over B fraction, as we are figuring out these calculations, hopefully again, you're making use of that lined space in each of the sidebars. This is going to be 3/10. And so our X coordinate of Andre's stop is going to be found by taking -15 and going 3/10 of the way down the distance of 25 minus -15 or +15. And the Y coordinate for Andre's stop here is going to be 2 plus 3/10 of the way down the vertical distance of 17 minus 2. And you guys, that is going to come out to be -15. Of course, my 10, this is 40 here, so 10 goes into 40 4 times, so -15 plus 12. And 2 plus our 17 minus 2 is 15. It's a minus. Common factor of 5 we can take out. And so we have 2 plus 9 halves. Dividing by 2 leads to a terminating decimal. That fraction is 4.5. So we have -3 and 6.5 are the coordinates for our point. That's choice C. See you in the practice.